So this is our last section of chapter 2. 2.7 is about graphing linear inequalities. We are going to practice it one more time tomorrow, and then we'll take 2 days to review all the sections for the chapter. So expect that your chapter test is on Friday. The steps to graph a linear inequality. The first thing that you want to do is to solve the inequality. Let's see if my pen will go. Now, usually it's for, these are linear inequalities, so you're going to solve the inequality for y. Now, normally, I'm not particular as to if you solve for x or you solve for y, but in this particular case, you want to solve it for y. The first thing you want to do next is you want to draw, if I can spell here, either a dashed or solid line, which we'll talk about in a minute as to when we know, oh, is it dashed? Oh, is it solid? We'll go over those rules. And then the last step is to shade the correct region. Okay? So solve the inequality for y. If there's only an x, you know that's a vertical line. It's kind of its own exception. But you want to basically solve the inequality for y. Draw either a dashed or a solid line. Make that look a little better. Shade the correct region. So those are the 3 steps to solve an inequality. Now, in our first example, it just says do the points, and then we've given the points 0, 0, 3, negative 4, and negative 1, 3 satisfy the inequality. And the thing to remember is if it satisfies it, it's a solution that is true. So it makes a true statement, okay? So it's a solution that it's going to be true. So we just have to check each of those 3 points. So if we check 0, 0, let's check 0, 0 in all of them. So let's do 0, 0 first. To check 0, 0, all we're going to do is replace x and y for 0. So we get 0 plus 0 is less than 5. Is 0 plus 0 less than 5? Is 0 plus 0 less than 5? Yeah, I mean, it's just 0 is less than 5. So that's true. So it's a yes. So 0, 0 works for the first one. Okay? It makes a true statement when we plug it in. Let's plug 0, 0 into the next one. We get 0 plus 0 is less than or equal to 0. Is 0 less than or equal to 0? Yeah, because of it, it has that equal bar in it. It's a true statement, so that's a yes as well. So if we were to graph it, we would see that that is in the solution set. Let's check 0, 0 in the last one. We get 0 minus 0 is greater than or equal to 6. Is 0 greater than or equal to 6? Is 0 greater than or equal to 6? Nope. So that's a no. Okay. So in this spot here, we checked 0, 0. So now let's check 3, negative 4. Let's check 3, negative 4. So every place we see x, we're going to put a 3. Every place we see y, let's put negative 4. So we're just substituting in and seeing is it a true statement or not. Okay, so we get 3. 2 times -4 is -8. Is that less than 5? Well, we get that -5 is less than 5, which is true, so that's a yes. So 3, -4 is in the solution space for that first inequality. Let's try 3, -4 in the second one. So 4 times 3 is 12. 4 times, or 3 times -4 is -12. Is that less than or equal to 0? Well, it is, because we get 0 is less than 0, so that's a yes. And let's try 3, -4 in the bottom one. 3 times 5 is 15. Now, when we subtract a -4, that becomes +4. So be careful of that. Is that greater than or equal to 6? Well, yeah, 19 is greater than 6, so it's also yes. So that point works in all 3 of the inequalities, so it would be a solution. And then finally, let's check, is that point, does that satisfy the inequality? Is it a solution? Well, if we plug -1 and 3 in, we get -1. We get -1 plus 6. Is that less than 5? Well, -1 plus 6 is 5. 5 is less than 5. Is that a true statement? Is 5 less than 5? No. So that's a no. Let's plug -1, 3 into the middle. So we get -4 minus 9, which is that less than or equal to 0? Well, it sure is. You get -13 is less than or equal to 0, so that's a yes. And then finally, if we plug it into here, so I'm just taking out the x, replacing it with -1 and that with a 3. We get -5 minus 3 is greater than or equal to 6. That is a no.
How do you get -9 for question 2?
Oh, okay, I'm sorry. I was plugging in -1, 3. So -1 goes here. That's the -4. 4 times -1. Or, I'm sorry, 4 times -1. That's that. And then here, 3 times, oh, it'd be +3, isn't it? It'd be +9. Thank you. Okay, let me show you again. I'm so sorry. This is -1 here. That's -4. That's 3. I was pulling the negative again. I'm so sorry. 3 times 3 is 9. That's +9, which is 5. So is 5 less than or equal to 0? That's a no. Thank you, thank you. Sorry about that. Okay. So I want to show you how you can check this on your computer, okay? Let me zoom in for you. So I want to show you, once everybody has their numbers written down, I want to show you how you can check this on your computer. Okay. Now, there's probably a way we can do a screenshot and take a picture, but I'm not sure on your touch screen how. So that's something we can explore later on. Okay. So I do want to explore that. But once you're ready, I want you to open up a tab in Chrome and go to Desmos.com. There's one that says graphing calculator, I believe. So once everybody has it written down, open up Desmos.com on your, yeah.
Can you go back up to the definition part? I was trying to figure out what I was doing, but
Okay, Desmos.com, we're all going to go there. We're going to play around with how to graph these, okay? Just so you see how to check your work. Okay, so if you go to Chrome, and in a new tab, if you type in Desmos.com, and then you want the graphing calculator, so that little green tab, okay? And then practice, let's type in the very first equation on our example. It was x plus 2y was less than 5. Okay, see what happened? Okay. Now here's how you could check to see if we were right. So in a new line, type in 0, 0. Another point we checked was 3, -4, so 3, -4. And then type in -1, 3. So those were all the points that we had done. And then you want to click label, so then a little point comes in. Okay. Now, what happened was, if you take a look, do you see how the 0, 0 point, which on mine is in blue, is in the shaded region? So that means it's in the solution set, okay? See how the green one, 3, -4, we got a yes? See how it's in the shaded region? Let's look at -1, 3. -1, 3 is its unique case. Do you see how it touches the line? If the line is dashed, like this one, that means that any point that's on the line doesn't count. So that's why that one became a no. So we got a yes for 0, 0. We got a yes for 3, -4. We got a no for -1, 3. And that's because it's on the line and our line is dashed. Dashed is like an open circle. It means it's not included. So try it out in Desmos.com. You hit the graphing calculator, that little green, it's a parabola and maybe a line through it. If you tab on that, you can check your work very easily on Desmos. So I want to encourage you to try it yourself, but use Desmos as a tool to check your work or find if you're making a mistake, okay? Everybody see how that worked? Okay, so I'm going to go back to notes, and I want to practice graphing, okay? Now remember the steps were to solve the inequality for y, draw either a dashed or a solid line, and shade the correct region. Let's go back up to our notes for a minute. I want to add a little note. We're going to do dashed if it has the equal to. We're going to do we're going to do dashed if there is no equal, and solid if it has an equal. Okay, so a dashed line, there's no equal to sign. Solid, there is an equal to sign. And where do we shade? So if we've solved for y, we shade above for greater than. We shade below for less than. Okay? So that's how we're going to make that determination. Now this is only if you can solve the inequality for y. It doesn't work quite the same for x if it's only x, but I'll show you how to do that. I think there's an example like that. But we make a dashed line, there's no equal to. Solid line, equal to. That's like open and closed for when we did just one variable inequalities. We shade above if it's a greater than symbol. We shade below if it's a less than symbol. So we'll add that little piece of information. Okay? Everybody got that written down? Okay. Now that we have that, we have the steps we want to follow. So we're going to solve it for y. Then we're going to look, do we have an equal to? If we have the equal to, it'll be a solid line. Otherwise, we're going to make a dashed line. And then, is it a greater than symbol? We'll shade above. If it's a less than symbol, we'll shade below. So that's kind of the main things you want to do. Those 3 steps are really a good rule of thumb as you're going through these problems. Okay? Now, if we look at our first example, step 1 is to solve it for y. We did. It's already done for us, and that's always wonderful. So step 1, we've solved it for y. Great. Okay? We can even think of that as 0x plus 2. If we put it in slope-intercept form, that's a nice way to put that 0x there to know that our slope, but it's going to be a horizontal line. Okay? So the second step, we draw the line. And we're going to draw our line. In this case, is there an equal to? No. So we're going to make it dashed. So we know that's a horizontal line at 2. So we're just going to go to 2, and we're going to make our line dashed. Okay. So however we know how to graph a line. That's why we graphed lines before we got to 2.7, because you need to know how to graph the line. So that is a horizontal line at 2. The third step is we either shade above or below. It's a greater than symbol. Greater than means we're going to shade above the line. So just take out, I think you have a highlighter tool most likely, and shade above the line. Now what that means is that any point in that region makes the inequality true. So this point works, this point works, this point works, this point works. Any of those points will work. We can't touch the line itself because there's not any equality. So it works all the way up until we get right to that line, and those points do not work. But anything above them are going to work just fine. Everyone okay with how we graphed A? So think about how would you graph y equals 2, but we're going to make it dashed. That's the only difference. If it was a y equals 2, we'd make it a horizontal line, but we just have to make it dashed. So we're going to solve for y. We're going to graph that line like it was a regular line, except is it dashed or is it solid? And then since it's greater than, we get to shade above it. Is that okay for that one? So dashed because it didn't have the equal to. Solid if it had that little equal bar. Okay, so let's move on to example B. Now this is the only one where we can't solve for y because there isn't a y. We just have to know that it is a vertical line, and we're going to draw x equals 3, and we're going to make a solid line at x equals 3. Okay, so that's the only time we can't solve for y. And it's only because it's a vertical line. It's our only case that's like that, so I wanted to make sure that we had one like that. So it's solid because and only because of that little equal to. So go over to an x value of 3 and make a solid line. Make a solid line. Now, this is the only time we shade left or right. How do the x's go less than? To the left or to the right? Left. And you can even think logically what x values are less than 3. 2, 1, 0, -1. So this is we're going to shade to the left. And so that's the only time where we shade left to right. Now, this time, a solution is directly on the line or any point out here in the shaded region. but we're allowed to be on the line. It works perfectly acceptable to be on the line. Some borders you can stand on and some borders you can't. This is a border where we can stand at x equals 3, and it's perfectly acceptable. So I wanted to show you one like that. So shade to the left for less than, shade to the right for greater than, only if there's only an x in the problem. That's the only time we do that, just if there's an x alone in the problem. Everybody good for that? Okay. Now let's do one where we actually have some solving to do. Now I said to solve it for y. Okay, so step 1 is to solve for y. I'm going to write it over here to the right so we have it. Okay. To solve that for y, there's one of 2 ways to go about it. We can just pop the y to the other side. But because this is an inequality, I need it to be y is greater than or less than all the other junk. So I need the y, I need the symbol, whatever it is, greater than, less than, and everything else. That's what I'm looking for when I say solve for y. So let's subtract off an x from both sides. If I divide by a negative, what do I have to remember for inequalities? If I divide by a negative, what do I have to remember? I got to change this sign in the middle. Now, I circle it so that I know, and hopefully because I can forget things very easily, that I have a little reminder on the page. So y is less than x. Now I've solved it for x. Okay. What we're going to graph on the page is we're going to graph y equals x, and we're going to make it dashed. The reason we're going to make it dashed is there's no equal to there, okay? And how do we graph y equals x? Well, I would even think of it as y equals 1x plus 0, right? Our slope is 1, our starting point is 0. So when we graph it, we start at 0, go up 1 over 1. We're going to make it dashed, so even making little dots along the way just to remind me how it works is okay. And really spread that dashed line across your graph paper. Okay, so you just graph the line y equals x, like we know how to do, slope-intercept form. But we got to make it dash because there's no equality. And next we have to shade. The y is less than x tells us that we have to shade below the line. So now we're ready to shade below the line. Okay? So solve it for y. Graph the associated line, dashed if there's no equal to, solid if there's an equal to, and then shade below if it's less than, above if it's greater than. See okay? Does that make sense? Okay. 3 steps. Follow those 3 steps every time. Solve for y if you can. Graph the associated line, dash your solid. Put the shading on. Above for greater, below less than. This one became a less than, and that's why we shaded below. And then you can always pick a point, like we could pick the point 2, 0. If we put it back in the original, is 2 minus 0 greater than 0? Yeah. So you can check any point in your shaded region, just pick one at random, stick it in the original version, it'll find your mistakes if you have any. Everybody good with C? Okay, let's do D. Number 1 has been done for us. So there's no solving for y. It says y is greater than 2x. Yay. So that part's done. If you want to write it 2x plus 0 so that you see both the slope and the y-intercept, you can. Our slope is 2, our y-intercept is 0. Are we going to make the line dashed or solid? Does it have the equal to with it? No, so it's going to be a dashed line. The line we're drawing is really y equals 2x plus 0, but we're going to make it dashed, okay? So start at 0, up 2 over 1, up 2 over 1, up 2 over 1. Sometimes I'll follow that pattern the opposite way to really stretch my graph across the paper and make a little dashed line there. This time, we're going to shade above the line. The reason we're going to shade above it is y is greater than 2x, means that we want the y's that are above or higher than the line. So this is above it. I look for where the y-axis is taller than the line, what's higher than the line, what y values are bigger than the line. So it's taking what we know about lines and inequalities, it kind of blends the two together. Remember, if you divide by a negative or multiply by a negative, you do have to flip that symbol. So solve for y, graph the line, either the dash or solid, shade above or below. And we have any questions about D? Everybody got that one?
Yeah.
Okay, let's do E. Now, for E, we do have to solve it for y, but it's a pretty nice procedure. All we got to do is subtract that x to the other side. So it's not a horrible thing to do. We get y is less than or equal to negative x plus 2. Now, I try to write it in slope-intercept form so that I see the line very clearly. This time, we're going to make a solid line at y equals negative x plus 2. You just make the solid line. And the reason we make a solid line is all because there's that equal to there. Okay? Okay. So we are going to start at 2. Go down 1 to the right 1. Our slope is negative 1. Down 1 over 1, down 1 over 1. You can always plug in points if you forget exactly how to graph that line. I make my line really stretch out, and you should too, because we need to shade stuff. And then it's a solid line. We don't make a dashed line this time. We make a solid line. So start at 2, our y-intercept. Go down 1 to the right 1. Down 1 to the right 1. Look at our finished version. See how it is a less than symbol. Our finished version is a less than symbol. So we have to shade below the line. When our finished version, it's all about the finished version, not the original, because you might have had to have turned it around. And we are shading, below the line. So you can find where your y-axis is below it, but it's under it. I think of under it. So it's all that area kind of right there. Any questions about 2, 7, this last example, E? So solve for y, graph the line, solid or dashed, shade above or below, and that all depends upon your symbol. Okay? Make sense? A little bit, kind of? Okay, so now we got your homework. Your homework is here, and you'll be able to just graph directly on there. That's what I want to see. So I kind of want to see over here those 3 steps. Basically, though, as soon as you solve for y, you can do the last 2 steps right on your graph paper. So you've got, how many is there? 10 graphs to do? Okay. So that is your job. Most of these Except these last two, they have solved for y for you, so that's nice. So then you're just dashed or solid, shade above or below. There you go.